Hi, my name is Yunfeng Shao. My project topic for the network science class is transportation network analysis using MATLAB. Transportation infrastructure of a country is one of the most important indicators of its economic growth. Here we study the topological properties of the airport network in the United States. This research can help transportation engineers and airline companies better understand the development of air transport. For example, through this project, we know how to pick the location of an airport and how to schedule the flights between different airports. To evaluate the properties of a real transportation system, we should first convert the system into a format that we can evaluate with the existing mathematical tools. The graph theory has been used here, but I would just skip this part because the network I used in my project was obtained from an online dataset. It's an undirected network. I use MATLAB to convert the edge list into an adjacency matrix. Then I can use this matrix to calculate some key factors of the network. First, the degree. The degree of a vertex defined as the number of edges incident on this vertex, which we've already known from the class. For the airport network, the node degree represents the number of airports connected to a certain airport. Therefore, the higher the degree, the more central of the airport. Then the shortest path. It can be simply understood as the minimum distance between two nodes. In my project, I ignored the edge weights, so the shortest path represents the number of flights passengers need to change when traveling from one airport to another airport. Shortest path analysis is intended to give us an idea about the ease of travel in the network. At last, I'd like to get the clustering coefficient. Here's the equation, how it is defined. Actually, the clustering coefficient just simply indicates the level that the nearby nodes tend to tie together. Alright, these are the major work I've done in this project. Let's see the results. Among the 496 airports, the highest degree is 135. The lowest degree is 1. The average node degree is 11.43, which represents the average number of destinations passengers can achieve from an airport. From this table, we can say that the majority of the node degrees are very low. The degree distribution fits the power law equation. It's almost overlapping with the power law curve. This proves that the airport network is a scale-free network. The average shortest path is 3.01, which represents the average number of flights need to be taken during per trip in the United States. The shortest path distribution also shows that 94% paths need at most 4 flights. The average clustering coefficient is about 0.63. Point, yes, 0.63. It's a relatively big number. Together with the small average shortest path of this network, we know it gives a feature of a small world network. Okay, now I will go through the demo demonstration part. Here are the MATLAB programs I've already opened. From the code, we can see the unweighted edge list is loaded and converted into adjacent matrix. Then the degree of each node is calculated. Let's run it. Here, the average is 11.43, and using the curve fitting toolbox, we can draw the degree distribution graph. X data is D and Y data is P. Curve power law. Look at this. The power law exponent is 0.926. Now let's run the program to calculate the shortest path. This process takes some time, like half minute. It's still processing. All right, we got the average shortest path is 3.01. And we are still waiting for the shortest path distribution. Okay. Here, we can see the shortest path distribution. And the graph drawing is same as before. So I just want to do it. Now let's go for the cluster. Wrong. And we got the average is 63, and these are the cluster coefficients of each nodes. All right. So consider all the topological properties of the network I've analyzed. I can conclude that the airport network of the United States exhibits the features of a scale-free network and a small world network. Thank you. That's all for my presentation.